So we're up to Chapter 4, Lesson 5, and this is mainly dealing with how to simplify when you have powers and how to combine different types of exponents. So the key concept here is remember that the parts of a power here is we've got the base and then we've also got the exponent. And basically what ends up happening is if you have a base like this example here, 5 to the third power times 5 to the fourth power, you can just add the two numbers together, there are the exponents, and you have 5 to the seventh power. Now it seems pretty straightforward. Hopefully this will make sense quickly. So for this problem here, it's just going to be 2 to the fifth power because it's 3 plus 2, and it's 2 is the base. 3 plus 2 is the exponents, so you just add them. For this one here, it's going to be 8 to the 12th power. For this one here, remember, 5, if it has no power, or if it has no exponent, excuse me, then it's just 5 to the first power. So this is just going to be 5 to the third power. This one here, you can add them all up. The bases are all the same, so it's 4, 4, 4. So 4 is going to be the base, and that's 6 plus 4 plus 3, 13. So I think you get the idea here. Again, same sort of thing here. You just have the base of 3, and then you add 2 plus 18 plus 5, so that's going to be 3 to the 25th power. Now, this works the same when you have variables. So for example, here, when we have x to the third power and x to the 12th power, it still is going to be x to the 15th power. This is going to be x to the 12th power. And then, this is where it gets a little bit more complicated, but I'm confident you got it. So when you have a multiplication like this, what you're going to do is you're going to multiply the numbers, 2 times 6. So those are the coefficients, the numbers in front of the actual variables. So that's going to be 12. And then you're just going to, x is the base, and then the exponent is 11 plus 8, which is just going to be 19. For this one here, it's going to be 5 times 3 times 4, and that's going to be 60. And then x to the 3 plus 12 plus 8, so that's 23rd power. So a word problem here, the sun evaporates 10 to the 12th tons of water on Earth, or the sun evaporates 10 to the 12th tons of water on Earth per day. Find the weight of water evaporated by the sun in 10 to the 5th days. So it's just going to be 10 to the 5th times 10 to the 12th. So it's just going to be 10 to the 17th. And this problem here, it says, Angel Falls in Venezuela is almost 10 to the third meters high. So that's almost a kilometer high. It would take about 10 to the third dust mites to form a line 1 meter long. How many dust mites would have to be lined up in order to equal the height of Angel Falls? So it's just going to be 10 to the third times 10 to the third. So it's just going to be 10 to the 6th dust mites. So there's another thing when we're talking about division. I know this slide is a little bit harder to read, but I will clear it up for you in a second. The quotient of powers property states that to divide powers of the same base, subtract their exponents of the denominator from the exponent of the numerator. And so I'll just give an example here. 2 to the 5th power divided by 2 to the 3rd power is just going to be 2, because it still is 2, and then 5 minus 3, so it's 2. So that's how it works. So yeah, I think this one's pretty easy to see. 15 to the 23rd power divided by 15 to the 11th power is just going to be 15 to the 12th power. It works the same for variables. X to the 16th power divided by x. Remember, x by itself is just x to the first power, so that's going to be x to the 15th power. Here, it says x times x to the 7th divided by x to the 5th. So x times x to the 7 is going to be x to the 8th divided by x to the 5th power. So that's going to be subtract x to the 3rd power. For this one here, you've got to simplify the numbers and also the letters. So 12 and 6, or 12 over 80, when you simplify this, what you're going to do is 12, and that's the number that goes into both those is, okay, so that's what that problem is there. So you have to simplify the 12 over 80 part. So 4 is the biggest number that goes into both those, so it's going to be 3 over 20. And then you have x to the 10th power divided by x to the 7th power, so it's just going to be x 10 minus 7 is going to be 3. And so that's how all this works. Again, similar thing here. 15 x to the 3rd times x to the 8th over 90 times x to the 12th power. So we're going to go ahead and combine the ones on top first. So that's going to end up being, let's see here, 15 x to the 11th power, and then 90 x to the 12th power. So this one here, it gets a little bit more complicated, but 15 divides into 90, so that's going to end up being 6 on the bottom. And then 11 minus 12 is actually negative 1. So it's going to be 1 up here because we can't have less than 1 up there, but it's going to be x down here. We'll get more into that in terms of negative exponents later. So if we were to simplify this expression, it says here 36 times 8x divided by 4 times x to the 4th. So let's do that part. So 36 8, then divided by 4x to the 4th. That's going to equal, well, it's going to be 9, because 36, or 4 goes into 36 9 times, and that's going to be x to the 4th power. So that's going to be that expression, and then over here we're going to do that one, and then we'll simplify it all the way. So it's going to be 42 x to the 5th power divided by 14 x to the 3rd power. So that's going to end up being, well, 42 goes into, or 14 goes into 42 3 times. Then we just do the subtraction, x to the 2nd power. So you end up with 9x to the 4th power divided by 3x to the 2nd power. So that's going to end up being 3x to the 2nd power. So really the most important things to understand here is when you multiply two powers that have the same base, you can just add the exponents and then keep the same base. And then when you divide powers with the same base, you subtract the exponent from the denominator from the exponent of the numerator, and then you end up with the same base as well. So good luck.